This is the answer to homework 9, question 3. So the question gives that x of t is the Poisson process where p of x of t is equal to k, which is equal to p of x of t equal to k is equal to e to the negative lambda t times lambda t to the power of k over k factorial. And so we're asked to prove or disprove that the limit of as t approaches infinity of x of t over t is equal to lambda. So there's a couple of tools that we use in order to prove this. So this question does get a little bit messy, but basically by Chebyshev's inequality, we have that the probability of the absolute value of xn minus x, which is greater than epsilon, is less than or equal to the expectation of xn minus x, the absolute value of that squared, over epsilon squared. So that's one piece of information that is going to be key in solving this. The next piece is that from the textbook we know that xn is said to converge to x in probability if the limit as n approaches infinity of the probability of xn minus x, the absolute value, is less than or equal to epsilon, is equal to 1 for any epsilon greater than 0. And so from another few pieces of information from the lecture and book, we know that the expectation of x is equal to lambda for any Poisson process, which means that the expectation of x of t is equal to lambda times t. Also for Poisson processes, expectations and variances are equal, which means that expectation of xt minus n, which we'll set as lambda, is squared, is also lambda times t. So going by this theorem here in the box, we can rewrite this as the limit as n approaches infinity of the probability that xn minus x absolute value is greater than epsilon is equal to 0, right? Because the other way around it's equal to 1. So then we can set, because we're looking to prove this equation here, we set xn minus x absolute value, we set that equal to x of t over t minus lambda. And the reason we can do this, it's kind of hidden in this, where we have the e of x of t, which was equal to lambda t for Poisson processes. We have that if you start rearranging that to find lambda, you have e of x of t over t is equal to lambda, and essentially e of x of t over t minus lambda would be equal to 0. And so here we're just setting like 0 equals 0. And so we plug this, so this that we rearranged from this box actually becomes the first piece of the Chebyshev's inequality here. And so we can plug in, once we've set this to x of t over t minus lambda, we can plug that into the inequality. So we have the limit as t approaches infinity of the probability of x of t over t minus lambda absolute value is greater than epsilon is less than or equal to the limit of as t approaches infinity of the expectation of x of t over t minus lambda absolute value squared over epsilon squared. And so what you end up with is, in the numerator you have e of x of t over, and then here you still keep your epsilon squared, and then with the squareds you end up with t squared on the bottom as well. E of x of t is just lambda t, so you end up with lambda t over t squared epsilon squared. And so the limit as t approaches infinity of lambda t over t squared epsilon squared is just 0. So therefore there's convergence, the same way that it says here. So then the proof is complete, and the limit as t approaches infinity of x of t over t equals lambda is true in probability.